So, good morning, ladies and gentlemen. I will first show you what is possible to do with 3D ultrasound in obstetric. And remember what was possible to do 40 years ago with unidimensional ultrasound. It was difficult to use. And what you can see here, this was one of the first transvaginal probe. This one, not really comfortable. But now we can use 2D, 3D, and 4D. And you can see on the lady face the impact of the visualization of the baby with the 4D. This was what was possible to obtain more than 10 years ago with 3D. And to do only one block, the acquisition was around 5 seconds and the rendering time was 1 minute. So if you want to obtain a video with a cine mode with 60 pictures, you have to wait 1 hour. And 12 years after, you obtain this result. The quality is really better, and the acquisition time is from half a second to 3 seconds for a 3D static, and the rendering time is half a second. And to do the same cine mode, you have to wait only 30 seconds instead of 1 hour. And also what we can do now is to use 4D. 4D, it's a real-time 3D, and you can go from 2 volumes per second to up more than 20 volumes per second. But the problem with 3D is it's a tool, it is a Swiss knife of ultrasound, but you have many tools, and it is really difficult to find a good tool. First, you have to know all these tools. Second, you have to know how to use this tool. And third, you have to know when you have to use this tool. But it's not so difficult. First, you have acquisition tool. You can do the acquisition with 3D, that means it's only one sweep, it's static. You can do acquisition with 4D, that means it's a real-time 3D. You can use also the cardio stick, and you can do the acquisition with or without color Doppler. The visualization, you can look at the complete volume. You can use a section inside the volume, and also you can choose the thickness of the section. You can use different rendering mode, surface mode for the external part of the fetus, and you can use also transparency mode, inversion mode. And you have some tools, electronic scalpel to remove some part around the fetus, and you can use the vocal software to do the volume measurement. First, the surface mode. With the surface mode, you can obtain this kind of picture, but you need amniotic fluid around the fetus or the embryo. If you have no amniotic fluid, you cannot use a surface mode for the external part of the fetus. You can do it in 3D, but also with 4D, and with 4D, you can see the grimace, the mimic of the fetus. And look at this one. I think it was a really sad fetus. You will cry. And some picture extract from a 4D sequence, and you can see between the picture you have less than 2 seconds, and you can see the different mimic. This is the surface mode, but you can use also the transparency mode. The first transparency mode is a maximum mode. With the maximum mode, you can see all the bones inside the fetus. And you can compare, you can clearly see all the bones and the sutures. This is a top view of the skull with a fontanelle. You can do it with 3D, but also with 4D. Another transparency mode is the minimum mode. With the minimum mode, you can see all the organ with fluid inside, also the blood vessel. The inversion mode. With the inversion mode, you will transform all the cystic part or all the liquid part into solid. And this has the brain cavity at only 8 weeks of pregnancy and using the inversion mode, the brain cavities. You can mix with the color Doppler, the cord insertion, a knot of the umbilical cord, and the brain vascularization. And also inside the block, you can do any section, and you can use this display, the tomographic ultrasound imaging. It is a multi-parallel section, so you can cut the complete abdomen, and you have all the section in one display. This is another example of the use of TUI. It was 12 weeks pregnancy with absence of nasal bone, and it's really difficult with only one picture to say that you have an absent nasal bone, because if you give this picture, maybe you are exactly in the middle of the two nasal bone, but you have all the section, and you can see here you have absence of nasal bone. This is not the one nasal bone, it's only the reflection of the ultrasound on the skin. When you want to do a section inside the block, you can do a section, but you can choose also the thickness of the section, and you will use a transparency mode, and you can see the difference, and you can improve the quality of the picture. And the name of this is the volume contrast imaging. You can use it on a static block, but you can use it also on real time. You can use it on the A plane. So this is a classic 2D, and the same, you increase the thickness to 5 mm with the minimum mode, and you can clearly see the aortic arch and the ductus. And you can do it also for the brain. Here, the corpus callosum. For the bones, the only things you have to do, this is on the C plane, the only thing you have to do is to put this line on the face, here, and on the second window you have in real time this view. I will show you after on the system, but you will see now in real time. This is the back of the fetus with the two scapula. The only thing you have to do is to put the line on the back, push the button, and you have the result. You can see the back of the fetus with the transparency mode. Here again with the head. This is a side view of the head. You put the line and you obtain all the skull's bones. On the heart, you will have a lecture on the heart, but if you do a static, static acquisition, you may have a motion artifact inside. So we use stick technology. With the stick technology, you can obtain a complete heart volume with one cardiac cycle in a loop, and you can move inside. You can do it also with color Doppler. You can display it with the tomographic ultrasound imaging, without color and with color. In this case, it was HD flow. And you can use it for the heart, but also for the pulmonary vein and arteries. And also you can use all the rendering mode. Here with the color Doppler, angio-Doppler, with a minimum mode, inversion mode, And on this heart with the inversion mode, you can recognize all the part of the heart. So, what are the real benefits of 3D ultrasound in obstetrics? First, you will give a more demonstrative picture. You can see here a fetus at 32 weeks and the same at birth and 2 years after. You have the same nose, the same lips. But if you want to see difference between fetus, the best view is a profile view, this one. And you can see here 32 weeks, all these baby face are different. Some are not really nice, others nice, but it is the same for the adult. Another series. And you can compare with baby at birth. So this is a help in case of fetal malformation. In case of cleft lip, harlequin fetus. This one was autocephaly and a trisomy 13. And on the trisomy 13, look at this, you can see the proboscis here and the strange face, but look also at the hand, you have hexadactyly. And is it a help for the Down syndrome? And you can clearly see the difference between these two faces. This one with a flat face, we did amniocentesis for this flat face. It was late in the pregnancy, 32 weeks, and this nice face. But the only problem is that the Down syndrome is this one, and the other one was normal. So only it is difficult with 2D, it is also difficult with 3D ultrasound to do the diagnostic of Down syndrome. Why we did amniocentesis for this one? Because of short femur and also a borderline ventriculomegaly. Now I will present you some face malformation, Pierre-Robin syndrome with a micrognathia, a Brackmann-Delange, Cornelia-Delange, Brackmann-Delange syndrome with oligodactyly, ectrodactyly, and hypoplasia of the mandibule, retrognathia. Apert syndrome with a typical face, the hand with a complete syndactyly, a case of trisomy 13 late in the pregnancy with a postaxial hexadactyly and the face with a micrognathia. And this is a top view of the skull with a defect of the two parietal bones. A macroglossia, a Beckwith-Wiedemann syndrome, achondroplasia, and with the hypoplasia of the middle face and the typical shape of the hand here. But it is really a help in case of cleft lip, cleft palate. In case of cleft lip, cleft palate, you have first to look at the lips to know if there is a cleft lip or not. After, you have to know if there is a cleft in the alveolar ridge. And after, you have to know if there is a cleft in the posterior palate. And this, the posterior palate, is really difficult to see. Some example, a bilateral cleft lip here, and also a cleft in the palate. It was easy on the 2D picture, but it's not so easy. The baby in 3D and after birth. Another case, a cleft lip here. And using the maximum mode, you can see you have no cleft in the alveolar ridge. That means there is no reason to have a cleft in the posterior palate in this case. And this was the same at 32 weeks, at birth, and after surgery. 3 cases of external cleft lip, but here you can see it's a cleft lip because you have no cleft in the alveolar ridge. Here you have a cleft in the alveolar ridge, and here it was a bilateral cleft lip and cleft palate. But the posterior palate is really difficult to see. Why? Because if you start with this view and if you do the acquisition from this starting point, what you will obtain in the block, you will have shadow here, 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 and the palate is here. So the palate is in the shadow. what you have to do this acquisition. It's not so easy to obtain. The acquisition, you have to do it from here. And if you do this acquisition, you move inside the block and you can clearly see the complete palate here. And this is a coronal view. This was a case of a bilateral cleft lip, a bilateral cleft in the alveolar ridge, but no cleft in the posterior palate. And you will see here, the posterior palate is okay. And this was using the TUI, the bilateral cleft lip here, but you can see here the posterior palate is complete. The same, I fly through the face, and you can see here the palate. But you can obtain this kind of rendering only if you do the acquisition from here. So this was this case. This is another case with a unilateral cleft lip, and using the same acquisition from here. This is the palate, and you can see here the complete cleft of the palate. The 3D rendering with the surface mode, and this was this case. I show you many cases with the surface mode and also the maximum mode, but you can use the inversion mode, a jejunal atresia, 2D and 3D, a pielectasie, hydronephrosis, and the 3D rendering. And limbs, club fit. It is really difficult only with 2D to show one club foot, and you cannot put the two club feet on one picture. On 3D you can do it. And this was the syndactyly of the fingers 3 and 4. A genu recurvatum. A case of spina bifida. In this case, you don't really need the 3D to do the screening of spina bifida, because the screening of spina bifida is here on the posterior fossa and the size and the shape of the cerebellum. But you can move inside here, and this is a view with all the nerves inside. And the 3D rendering, we just cut a part of the skin, and you can see inside. Real benefit of 3D ultrasound, more demonstrative. Also, you can do any section plane inside. You can use the TUI. This was a septal agenesis, 22 weeks, with axial view, with a coronal view. So you don't need video, you can only give this picture. Nuchal translucency increase in case of trisomy 18. Hydrothorax, 22 weeks. Another real benefit is the use of the maximum mode, because with the maximum mode you can clearly see the skeleton. It's not possible to obtain such picture with 2D. Why? Because when you work with 2D here, you can see only the surface of the bone, and you can see only the crescent of the moon. And when you work with 3D, you turn and you can see the coronal view, you can see the C-plane here, and you have the exactly shape of the femur. And here on 2D, you have not the idea of the exactly shape of the femur. The occipital bone, some examples. The classic occipital bone, sometimes you have variant with incomplete fusion of ossification buds. You can see Vorbean bones in the posterior fontanelle here. Sometimes you have 2, 4, 1, asymmetrical. The shape of the skull bone in the early pregnancy with the normal, 30 weeks. a case with trisomy 13 and holoprosencephaly with a closure of the metopic suture, absent of nasal bone. A trisomy 18 with absent of nasal bone. A case of eye drops with normal karyotype, but you have also a closure of the metopic suture. And this was occipital cephalocell, and also you have a closure of the metopic suture. You can do it also later in the pregnancy. This was an abnormal metopic suture, and it's really difficult to suspect it with 2D ultrasound. It was a cat-cry syndrome with a K-hole shape. This one with additional bone in the metopic suture. You cannot suspect it. It's really difficult to suspect it in 2D ultrasound. This one, it was a hydranencephaly with, in this case, you have a hypoplasia of this frontal bone. This was a Dandy-Walker syndrome, and also you can see the metopic suture is abnormal, open. And this case was sent to me with abnormal face, and you can see on 2D with the surface mode, you have a cleft from the nostril to the eyes, and also a skin tag here. And using the maximum mode, you can see a defect here, and also here. The ribs, you can easily do the count of ribs, and in this case you can see you have 11 ribs here, but 12 ribs on the other side. The normal is 12, and in this case you have only 11 ribs. This one you have 13 ribs. This one you have 14 ribs, and I stop here. I don't yet have 15 ribs. Heart examination, you will have a lecture on it. What I prefer for the heart is the display with a TUI, because with a TUI you can clearly see the complete heart. This was a case of hypoplasia of the right ventricle. The left ventricle is here. You can see the aorta, and you have a really tiny pulmonary artery here. And this was a hypoplasia of the left ventricle, and you can play also with the inversion mode to show it, but you don't really need the rendering mode. The best is to work with the TUI. Another example, this is a VSD. This is made with, where is a VSD? It's difficult, but if you look at the complete picture, you can see here the VSD. So when you give only one picture of the heart, maybe you have a VSD, but you are not you don't do exactly the section on the VSD. What we can do also, we can do volume measurement. If you use the vocal software, we can do volume measurement of the placenta, but you cannot do it after 22, 25 weeks because the placenta, you cannot put the placenta complete inside the block. It's too large. You can do a volume measurement, bladder, stomach, liver. And also, you can use the inversion mode and using what we name the volume threshold. And in this case, it was possible to obtain the volume of this. This is not a lung. It is with inversion mode, all this part, the hydrothorax. So it is possible to obtain the volume of the hydrothorax alone. And what will be the future for the 3D and 4D ultrasound? First is the improvement of 2D. But I did this slide 1 year ago, and this is not the future, this is today now, because we have now a really high frequency probe. This was made with this high frequency probe. And if you improve the quality of 2D, you will improve also the quality of 3D. Look at this. The size of the embryo is only 16 millimeter, made with this new probe. And another one at 10 weeks. It was 31 millimeter, and you can clearly see the midgut hernia with intestine inside. We have also to improve the 4D, because when you are using a 3D, the quality is perfect. If you use 4D, the quality is less. If you use 3 to 5 volume per second, the quality is acceptable. But if you want to go up to 12 to 20 volume per second, this is not really nice. The frame rate is okay, but the quality is not good. Why? Because we are using an electronic probe with a mechanical sweep. And the next step will be, but I don't know when, 1 year, 2 years, 5 years, the use of the complete matrix probe without mechanical sweep. What we need also, we need an easy-to-use equipment, like this one. And I always try to do, during my 2D screening examination, a picture of the baby using the 3D tool. And this is all over the year. My success rate to obtain a 3D picture in the first trimester, second trimester, and third trimester. And you can see now I am around 90% of success to obtain the face of the baby or the complete fetus in the first trimester during my 2D examination. And in the third trimester, it's more difficult. Why? Because you have no amniotic fluid around the fetus, and this is really difficult. And the big step was the year 2001. It was the launch of the new system of the 730. And what could be the 5D? Maybe this. You can see twins. And this one doing a gas pass. And the other don't like the odor of this. Now I will show you some nice picture of fetus during the pregnancy. What is this? This is not Mozart. It's not Michael Jackson when he was a part of the Jackson 5. It's only the face of the fetus, the head of the fetus inside the placenta. The frightened fetus, fetus trying to think, smiling, fetus sucking his thumb, but this one is sucking his big toes, and this one is looking his penis here with open mouth, I don't know why, and this one is a real boy. This fetus don't want to see what's happened. The kiss, cute, nice. But look at these twins. This one is smelling the bottom of the other one. And you can switch to the maximum mode, and with the maximum mode you can see inside. So this was a lecture on the use of 3D ultrasound in obstetric, but especially in the second trimester of the pregnancy. Now I will show you what is possible to do in the first trimester of the pregnancy. And in the first trimester of the pregnancy, the main difference is you can obtain the complete fetus inside one block. And in the second and third trimester, you can obtain only a part of the fetus. And in the first trimester of the pregnancy, you can do the scan with abdominal probe or with a transvaginal probe. If you have to do your screening, you can do all with the abdominal probe. But try to use a transvaginal probe because the picture is really better, the quality is really better. So you can do the acquisition with abdominal. I always start with abdominal because sometimes to do the nuchal translucency measurement, it's easier with abdominal probe. And after I finish with the vaginal probe. And with this, you obtain a volume, a block with a complete fetus or embryo inside. With this, what you can do, always the same, you can do a virtual 2D, you can do any section plane inside, you can do volume measurement, and you can use the 3D and 4D rendering. The virtual 2D, if you use a vaginal probe, sometimes the fetus is not in correct position and it's really difficult to move. So you can take a block, a volume, and after you only have to rotate inside the block to obtain the C-plane. And in this case, you can do the measurement of the chondrum length. But the C-plane, sometimes it's not really good, and you can improve it. I will show you after how to do it. This is a C-plane. And if you choose the VCI, that means you don't work with a section, but you work with the thickness of a section, you can obtain it is exactly the same, in the same position. This is a section, and this is using VCI static with 2 mm of thickness and X-ray, but with the transparency mode. Here, you cannot do the measurement of the nuchal translucency, and you can do it here. Another example of the use of the C-plane without and with the VCI static. You can do volume measurement using the vocal software. This is in the early stage of the pregnancy. You can see the gestational sac. Inside, you have the amniotic cavity with the embryo also inside. And the external part is the extraembryonic cellum. And to do the measurement of this part, you can use the vocal software. The only thing you have to do is to draw the outline. In this case, I draw the amnion. I choose 30 degrees. And when it's finished, the software will give you the exactly volume of the amniotic cavity with the embryo inside. Here. This is not the exact quantity of amniotic fluid. It is the amniotic fluid with the volume of the embryo. And I did many measurements. This is the volume of the gestational sac, the chondrum length, and this is the volume of the only amniotic cavity with the embryo inside. And you can see the difference. And now, using the volume threshold, you can do also the measurement of the volume, the complete volume of the embryo only. 3D rendering, you can use different kind of 3D rendering, transparency mode, and different kind of surface mode. But in the first trimester of the pregnancy, you will use especially the surface mode. But you have to use the electronic scalpel, because if you don't use the electronic scalpel, sometime in the first trimester of the pregnancy, you will obtain this. A part of the trophoblast is in front of the fetus, so you have to cut it. You have to open windows. And if you cut here, you will obtain a part of the fetus with a black background. Okay. You can use also 4D. Now some example of normal pregnancy, 6.5 weeks. The embryo is here. This is a yolk sac. 7.5 weeks. 8 weeks with brain cavities, the back, the limbs, the umbilical cord. brain cavities. 9 weeks with the hand, fingers. 10 weeks with a typical position of the feet here, the umbilical cord and the midgut hernia. This is the midgut hernia. You can see here on 2D the presence of intestine inside the umbilical cord. (11 weeks). (12 weeks with maximum mode, loop of umbilical cord. At this stage, the midgut hernia disappear. 13 weeks. The umbilical cord. Here you can see the complete umbilical cord and the attachment of the cord on the trophoblast. The umbilical cord here, around the arm, around the neck, with a loop of artery, and all these pictures were made at 12 weeks, and you can see the difference. This was made with the old transvaginal probe, and these 3 pictures were made with the new high frequency probe. And 15 weeks, that means this is the end of the first trimester of the pregnancy, and after it will not be possible to have the complete fetus inside one volume. Now I will show you some example of fetal malformation, but only I have made a selection after 10 weeks of pregnancy, and I will show you always 2D picture and 3D picture, because you don't start the screening with 3D, you always start with 2D, and in case of if you think that there is a malformation, you will complete with 3D. So 2D for screening. A case of acrania. The brain is developed outside of the skull here. You can see a cleft lip, cleft palate in the first trimester of the pregnancy. This was a bilateral cleft lip and cleft palate 12 weeks. Another case of cleft lip at 12 weeks. It was really difficult to see here. And this is a palate. In the first trimester of the pregnancy, it is really easy to have the view of the palate because you have no shadowing here. And this was a 3D rendering at 12 weeks with the cleft lip, the cleft in the alveolar ridge, and the cleft in the palate. And the same fetus at 36 weeks and at birth. A case of holoprosencephaly, it was a trisomy 13. This is a normal brain with a septum between the two horns, the frontal horn of the lateral ventricle. In the case of allobar holoprosencephaly, you have a single horseshoe ventricle. 3D rendering using the inversion mode, you can see only a single frontal ventricle. And the same case, what you can see also, a small omphalocegle and a postaxial hexadactyly. And this was the skull of this fetus with abnormal metopic suture. This is normal, and this is this case, and also absent of nasal bone. Amnion rupture sequence, a part of the fetus is developed outside of the amniotic cavity. You can see here the amnion. This is developed in the extraembryonic coelom. It was a body stalk syndrome. Some abdominal wall defect here, omphalocele, 2D, 3D, 4D. A gastroschisis with the intestine floating inside the amniotic fluid. The 3D rendering with the intestine here and the umbilical cord here. A megacystis, 13 weeks, with a pielectasy. 3D rendering, you can cut inside, and 3D rendering using the inversion mode with the megacystis, the stomach, and the pielectasy here and here. Limb abnormality, ectrodactyly with only 2 fingers on this hand, only 1 finger, and the feet with only 2 toes. This baby with syndactyly here and here, hypoplasia of the forearm, and a case of ectrodactyly. 12 weeks. This one, postaxial hexadactyly. I did the scan with 2D ultrasound, and when the scan was finished, I saved some blocks. For me, the examination was normal, and after, I worked with the blocks, doing a 3D rendering, and on the 3D rendering, I saw this, but I miss it with 2D ultrasound. After I take the lady again, and you can see with 2D ultrasound the postaxial hexadactyly here. Also, this scan was made at 14 weeks. For me, the scan was normal. At the end of the examination, I did a 3D scan to show the complete fetus, and I saw this. First, I thought it was a reminder of the yolk sac, because sometimes you have the yolk sac. The yolk sac is always present, but going back to the 2D ultrasound, you can see here something. It was an early stage of the sacrococcygeal teratoma. And the same at 26 weeks. It was huge, and the volume was more than half a liter. A case of a triploidy with a typical aspect with a huge head compared to the body and the hypoplasia of the mandible. And this case, also you can see spina bifida. It was this case of triploidy with the spina bifida here. And the nuchal translucency, 10 weeks of pregnancy using the VCI static here and the 3D rendering with surface mode. A trisomy 18 with a large cystic hygroma, and another one with a cystic hygroma. So the benefit of 3D ultrasound in the first trimester of the pregnancy, first is to obtain any section plane. If you cannot move, you have to take a nice volume and you can move inside. And if you can do this, this is a help for measurement. You can do volume calculation, and you can use 3D and 4D rendering, especially to do an accurate checkup of fetal malformation. I will open some case on gynecology and to show you how we can work with a block. First, I start with the gynecology. What is this? This is the uterus in the just before the menstruation, just before period, and you can see the endometrium is white, and it is the best time to do 3D of the uterus because you can clearly see the uterine cavity. If you want to see the uterine cavity, what you have to do? You will rotate this part, but first you will see how to improve the quality. This is a section inside the block. You can move inside, okay? And I will use static VCI. And static VCI, I always choose in random mode the X-ray mode. X-ray mode, it's okay. And now you can see the difference. I will go on the full window, this one. This is with VCI static, and this is without. Because here you choose the thickness here. You can go to 1 millimeter to 20 millimeter thickness. I always choose in gynecology around 2 and 3 millimeter. After, what you have to do, you turn like this. like this, and you put the dot on one horn, you find the other one, and here you have the complete shape of the uterine cavity. So if you want to train with how to move inside the block, gynecology is really, uterus, you can start with this because you can really understand what is the C-plane. We will do it with the intrauterine device because it's more easy with the intrauterine device. You have the intrauterine device here. The acquisition was made here. So I put the dot inside. Now I will use a section plane, and after I will improve with a static VCI. You turn like this. You turn, and you can see the intrauterine device inside. Sometimes it's difficult to find all the parts, but what you have to do is to take this one. This one is perfect. You put the dot here, and now you will try to find this one, rotating like this. Okay, you have the two parts, and now I will do the rotation like this, and you have the complete uterine device. You want to use a static VCI? We will try to use it. This is, it was static VCI, but static VCI, you can increase the thickness. Take this one. And random mode, in this case, you can use X-ray, but the best is to use the maximum mode. Why? Because it is white, and if I put maximum mode, you can clearly see the intrauterine device, and you can mix the two. What is this? We will start with this one, static VCI, and you can see the endometrium here. I will turn. And you can see a bicornuate uterus. This is nice. You can use a TUI, and you have all the section. You can play with the distance here. And also what we can do is to use the random mode. This is a box of visualization, and you look from the green line here. I will change the direction to obtain this view. I reduce the size. And now I will play with the threshold. And you can see the two endometrium. And if you use a magic cut, you go behind, you cut this part, and this part, and you can see the two parts of the uterine cavity. This is the uterus. I will use a static VCI. And when you move here, look at the C-plane. What you can see here the interstitial part of the tube. One ovary. So you can move inside. I can choose render. And I change the direction to take, that's this one. Okay. And the result here is the 3D rendering of the ovary with follicles with surface mode. But you can use the inversion mode. The only thing you have to do is to put the ovary inside the box. And random mode, inversion mode, you play with the threshold. I prefer to use a gradient light. And here you have the ovary with all the follicles inside, and you can cut around. And you can see the shape of all the follicles inside. This is one embryo, the brain of 8-week embryo. I will show you how to obtain the brain cavities with inversion mode. First I play magnify. You put the head inside the rendering box here. And random mode, inversion mode. I increase the threshold. And now I will use the magic cut, full window. And what you have to do is to cut this part. Here again. Okay, and this is the brain of this embryo, and you can increase the threshold. When you increase the threshold, you will feel all the part, and you can see. And you finish cutting this. This is, it was around 11 weeks, a fetus with nuchal translucency. And you can understand the acquisition was made like this. This is a C-plane. The quality is not really good. So VCI static, and I use random mode, X-ray, it's okay. And I prefer to use, change the gamma color, to use this one. And you can play with the curve. With this, you play with the brightness and the contrast. And now you can see the difference between this and without. So you can really improve the C-plane using the VCI static. But the result is not so good on the A plane and the B plane, but it's really good on the C plane. This is early pregnancy, 11 weeks, but something is wrong. I will use magic cut. I cut this part. And this is a fetus, and you can see the head is huge compared to the body. It was a triploidy. So thank you for your attention.